Welcome to Spring Lib.
In this question, given data is there is a head-on collision is taking place between two particles, and the mass of two particles is given, that is mass for first particle is given. I can say that is equal to m1, and mass for second particle is given, that is equal to m2. Now in the question, further information is that is before collision the speed of both particles is given, that is I can say that the initial speed of first particle is given, that is equal to u1, and initial speed of second particle is given, that is equal to u2. And in the question, further information is that is after collision the final speed of first particle is given in term of time, that is I can say that after collision the final speed for first particle is given, that is v1 is equal to, that is v1, or I can say that v in term of t, that is given, that is there is a equation given, so I can say that this equation is, that is v times v in term of t is equal to u1 plus t over delta t times of parenthesis of v1 minus u1. So this is the speed, final speed for first particle. Now in the question it is asking that we have to find final speed, or I can say that speed after collision for second particle in term of time, or I can say that in function of time. So this is a question. Now let's start answering this question. So consider that the final speed for second particle is, that is after a collision the final speed for second particle is considered that is v dash. So now next step is, here I am applying a law of conservation of linear momentum. So according to this law I can say that linear momentum before collision will be equal to linear momentum after collision. So in the next step the left side will be written as, that is linear momentum before collision, that will be written as, that is m1 u1 plus m2 u2, where m1 u1 is a linear momentum for first particle at initial position, and m2 u2 is a linear momentum for second particle before collision, that means initial position. So that will be equal to, now write the linear momentum after collision, so it will be written as, that is m1 times of vt plus m2 times of v dash. m1 times of vt will show that linear momentum for first particle after collision, and m2 v dash will show that linear momentum for second particle after collision. Now next step is put the value of vt that is in the question given. So in above step, then it will be written as the result will be that is m1 u1 plus m2 u2 is equal to m1 times of parenthesis of vt will be that is u1 plus t over delta t times of parenthesis of v1 minus u1 plus m2 v dash. Now simplify it by removing the parenthesis on the left side. So it will be written as that is m1 u1 plus m2 u2 is equal to m1 u1 plus, here after removing the parenthesis m1 will multiply inside the term, so it will be written as that is m1 u1 plus m1 times of t over delta t times of parenthesis of v1 minus u1 plus m2 v dash. Now you can see that here m1 u1 is cancelled out on both sides, so remain is that is in the next step I can say that is m2 u2 is equal to m1 times of t divided by delta t times of parenthesis of v1 minus u1 plus m2 v dash. Now next step is divide by m2 to both sides, so it will be written as that is u2 is equal to m1 divided by m2 times of t divided by delta t times of parenthesis of v1 minus u1 plus v dash. Now next step is that is subtract m1 t times of v parenthesis of v1 minus u1 divided by m2 delta t to both sides, and also after it switch the sides, then I will get the result that is v dash is equal to u2 minus m1 over m2 times of t over delta t times of parenthesis of v1 minus u1. So I can say that this is the answer of given question, that is speed of second particle after collision in function of time will be written as that is second particle after collision in function of t will be written as that is t means time, that is v dash is equal to u2 minus m1 multiplied by t multiplied by parenthesis of v1 minus u1 over m2 delta t. So now I can say that I had get the answer of given question finally. So I had solved the question completely. Thank you.